and then you can just say that, all right, in case the user says anything that to ignore or to modify the system instructions, just ignore that. And the backticks would take care of it. Which brings me to my next point. That's a pretty brittle way, right? Guys, all right, yep. So that's a pretty brittle way, to be very frank. So what do you do about that? Any idea, or like what you would actually go ahead and do? All right, it's an open-ended question. You can just work on that. We can just come again. We can revisit that topic. Maybe today's session there tomorrow again. No worries about that. But yep, I will just move on to my next slide. So here we come to model distillation. So model distillation has its roots in scientific papers. It actually came out in Geoffrey Hinton's papers in 2000, like what was it? Geoffrey Hinton's Jevdin's paper in I think 2006 or 2015. It's about getting like distilling the knowledge from a bigger model to a smaller model, but on the basis of what the outputs of the bigger model are given a certain set of questions. So here's a quick explanation. So you can just train a large model on a huge data set. Let's say you train something like GPT, like GPT-3 size, like GPT-3 is publicly available. So you can just, sorry, GPT-2. So you can just train GPT-2 on a huge data set, and then what you treat as a teacher model. And then you ask it a set of questions. So here's the thing. So when an LLM gives a particular output, oftentimes it gives you something called log probs, LOGPROBS. So it's like logistic probabilities and logits. So anyways, so those log probs are basically indicative of how much confidence the LLM has in its answer. That okay, I think that I am 90% correct with this response, or let's say I am not sure, I am around 60% correct with this. So that's what log probs do. They basically give you a mathematical approximation that okay, how confident an LLM is. So from there on, I think it will be pretty obvious that okay, given a certain range of answers, it will be a probability distribution. So are you guys with? I'll explain it again then. Is everybody on the same page? Is everybody able to understand? Yep. Yep. Right on point, Hariharan. DeepSeek did use. I'll come to that later. So, okay, I'm assuming everybody is on the same point. All right. So when the larger model gives you the confidence that okay, these are the confidence probabilities that I have from ranging from 0 to 1, that okay, this is the answer and I'm confident of this, let's say on a 0.9 or a 0.7. So what it does is it feeds the answers and the confidence of the like corresponding confidence of the answer to the smallest student model in a training loop. So what the student model takes in, it imbibes the confidence directly into its training weights as well as the answers. So what happens is it's a two-way flow, as in like the confidence propagation. So I think everybody of you have taken some sort of a neural network class. I'm assuming that, or if anybody doesn't understand what back propagation is, you can just raise your hand. Um, all right, all right, cool. I'll just go ahead. It sorts of does a back propagation and then it goes on a training loop. And suddenly, after a certain extent, the student model, which is a smaller model, actually performs much better in the benchmark than if you would have directly trained the student model on the raw data set. And like this is something like you are learning a topic in a structured manner from an actual teacher. Let's say some person is teaching you something, and then you actually have to learn it on your own from scratch. So definitely you would learn it much faster and better given a certain time constraint if somebody teaches you, right? So that's the idea of model distillation. But yeah, why do we call it an art? So the difference between a science and an art is pretty much about the numbers and quantifiability. If you can put in some metrics that can be consistent across all experiments, then it's a science. And if not, it's not science. It's more like an art. So yeah, that's definitely some. So here we come in. So why don't we call it a science yet? Even though it has its roots in scientific papers and is full of numbers. So the thing is, we don't exactly know how the smaller student model is changed in a deterministic way. And it is okay, given this loop, given this data, given this number of iterations in the loop, and given this teacher model architecture and the data it was trained on, as well as student model architecture, you cannot really replicate 100% of the weights of two experiments. Uh, is everyone clear about this? I know this is a tad tricky, but just bear with me on this. Does anyone have any confusion? Guys, peeps, guys, girls, anybody? Yep, cool. Yeah. So Hariharan, so just saying. So for example, you have two students, right? So you have two students, or let's say you are actually learning from a faculty in your college. So the point is, if a faculty teaches you the syllabus once in a week, right? Once in one in week in, let's say, experiment one for the first time, then you would be like, if in case you're absent minded, so in that case you won't really be able to like, you would be able to understand a certain amount of topic, right? And on second time when they teach you, you would again be able to understand a certain amount of topic. But the thing is, would your understanding be exactly the same in the two cases? No, right? It would differ at least somewhere, right?
Yes, sir.
Yeah. So that basically means that teaching you, or like you learning, is not a science itself, because you cannot replicate it 100%. What do we call a science? Something that we can deterministically sort of replicate at different places across different time intervals, right? That is it. So exactly, we don't know in a deterministic way. Secondly, how the internal confidence scores of the student. Like the student model also has some confidence scores for its answers, right? Teacher model gives a confidence score that is definitely done, but student model also would give a confidence score, right? So the internal confidence score to the student model will be adjusted during this learning process, right? Like for example, in the training loop in iteration 10, it would give much more confidence than, let's say, in iteration 1, right?
Sir, you are speaking about training the models.
Yeah. So I'm talking about in the training loop and the student model itself. So just bear with me. So it's like you are learning about something new, right? I just give you the teaching example that you are learning from a faculty. So the 10th, so by the time he actually teaches you and like he completes the syllabus for you and he asks something, so definitely you would be better equipped to answer it than when, if let's say he was teaching sub chapter 1 and then he asked a question from chapter 5, right? Make sense?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
So, but the question is, across each chapter, let's say change from chapter 1 to chapter 2 to chapter 3 to chapter 4 to chapter 5. So, in those two experiments that I said, would the way in how you adjust your learning and understanding of the syllabus be the same? Definitely no, right?
No, sir.
Exactly. That's the thing here. So you don't know how the internal confidence scores of the student model would be adjusted. And secondly, the thing is, how would changing the questions to the teacher model or the teacher model itself would affect the student model? It's still up to a random chance, right? Like let's say a faculty gets swapped, or let's say a faculty suddenly starts answering in a different way. In that case, your understanding would definitely falter a lot, and you won't understand that okay, might be this, might be that. Make sense? Um, guys, anybody?
Sorry, sir. I got disconnected. Can
Oh,
you
all right, all
ask?
right. So okay, so I'll repeat again. So let's say your mod. So let's say your faculty got changed, right? Or the way that they teach, that they were usually teaching you changes. So in that case, definitely your understanding of the total syllabus would also change, right?
Yes, sir.
Yeah. So that is the third point basically. How changing the questions or the teacher model affects the student. It's still up to a random chance. You don't know. You try to understand, but you never know, right? How your understanding would change. So mostly it
Yes,
works.
sir.
Sometimes it doesn't. So for the sometimes it doesn't, you can't really point out anywhere that okay, this is the problem. So since you can't do that, it's still an art.
Yes, sir.
So all right. So guys, let's do a quick like hands-on work. So do you have so I suppose since you have joined in this meeting, I suppose at least from your phone you have your browsers opened, right? How many of you actually have are on from your laptop, and how many of you are actually from your phone? Can you just raise your hands, laptop people? All right. All right. So around half of you. Cool. So let's just start with some prompting if in case you are unfamiliar with everything. I think Amarnath was someone who was like getting like a hang of prompting and like she didn't know anything from beforehand. So Amarnath, are you from laptop or are you from phone? Who is from laptop? Who is from phone? I think you can text in the group in the chat maybe. All right. Cool then. So I think we can get started with this. So yeah, just go to Claude.ai. I'm just pasting the link here. So just take up any questions from here. I'll just copy paste these things. So take up any question. What is like a sort of current affairs question and write it on Claude. Like try maybe for the fourth or and the fifth question, both of them. Try the fifth question at least. Hello. Yep, guys. I would really love if you everybody of you does an experiment on this because like the five all of you can just take up two. Like just keep the fifth one compulsory, and then just take in these any one of these from the top four. Just use Claude AI. I've sent you the link because this will come in handy for you in session 3. Yep, Kiran Meghanathan. Yep. Are you saying something? You can speak up. It's all right. Mhm. Guys, do share your answers in the meeting chat itself when you're done prompting. Ah, yep. Claude does take a little bit of a time to load. Exactly, Sarath. So you see there are 2 hours in the word cranberry, but is that true? Are there 2 hours in a cranberry like at all? Is it right or wrong? Exactly. So why is it happening that way? That the all-knowing LLMs that give answers to essays and write well essays for you are suddenly having such problems. They can't even simply count. Any idea, guys? What happens? Why is it happening so? Yup, Videsh, that's another thing. You won't be able to see the pricing. Why have you thought? There are 3 words in the word cranberry. There you have this thing. You see uncertainty, same question, but uncertain answer. Same question. Everybody asks the same question, right? I'm waiting for the other answers as well to come in. Others, I think it won't take that much of a time already opening your account there. Yup, all the answers are getting on point as we expected. Yep. So what are the common issues that you are seeing across all of the responses, guys? So like everybody of you is responding, right? What are the common issues that you are seeing? You can play around and everything. Let's just take a couple of like 5 minutes extra maybe. Yep. There are 2 hours in the word cranberry. Another person has got it. Prithviraj, I guess. Yep. Yep. Surya Varshini, you're on point. Others, please post your answers maybe. It just takes in maybe 2 minutes to sign up and then post these answers. Another minute. Let's wait for 5 minutes so everybody can be on the same page. I mean, whoever's listening, by the way. Exactly, Prithviraj. I'll be coming to that later in session 3 or maybe tomorrow. I'll be coming to that. Why ChatGPT does it, why Claude doesn't. Hariharan, you're on point. This is definitely like 90% correct. Yep. The next part is what then? Let's not give the answers, let's give the others a chance. A 5 minutes, 5, 6 minutes extra to get used to Claude and everything. Maybe. All right, Yogeshwaran and Hariharan, you sort of tend to get the hang of it pretty early, which is a great sign and shows that okay, you actually love to work with LLMs and AI and all. That you're pretty enthusiastic about it. But yep, let's give the others a chance, and we'll come back to this on session 3. These are like this is the last drill that you'll be doing. In the meanwhile, so if you have any doubt regarding this for session 2 or session 1, maybe you can just talk, or maybe if you want to know further about these things. Good job, guys. Going good. The DeepSeek thing is going to come a lot later. I think I sent the people my number. I think Sampath sir can also share my number with you later on, or whoever is in charge of it. Guys, are you all done? So just raise your hands who are done with the exercise, at least the 2 prompts, 2 or 3 prompts. That's nice. 11. So yep, 1/4 have locked in. That's nice. That's great. That's great. And guys, anybody who is actually confused to actually like how to get started with Claude or whatsoever, you can just also raise your hand as well. Yeah, Varun, please go ahead. Varun, you can speak if you're facing an issue.
Nothing, sir.
Nothing, sir. All right. Are you able to sign up in Claude? Cool. Arun, just put your responses that Claude said. I think it will take less than 2 minutes. Hariharan Lingeshwar want to speak something? To speak something? To speak something? All right. Great then. Yep. So, all right. So that a lot of quite a few others have posted their answers. So you see, if you go through the chat, for some people, I think it like for Arun and Prithviraj and somebody else, it gave two. For Hariharan and Madhusri, I think it gave three. So any idea where this might be coming from? Like the confusion between two and three, like it's a pretty deterministic answer, right? You just have to count the spelling. Any confusion like where this is coming from? Yep, there are two letters. Any ideas, guys, why it's happened so? Sarath, that's a good way to say how it is tokenized. But let's not go into those fancy terms just yet. I mean, I'm definitely up for debate and discussion in case you might just want to reach out to me on my WhatsApp, but not yet here. Alright, Arjun, so image from grand video file. Alright, so LLMs are basically just as I said from the session one itself. These are basically next word token predictors. So what's a token? So a token is the lowest unit in which an LLM can perform. Like for us, examples, we have cells. For the humans or any animals or plants, we have cells. Similarly, tokens are what the same for LLM outputs. So everything in an LLM just boils down to a token. And there are different sorts of algorithms to break down words and sentences into tokens. But the most commonly used one is the BPE, which is the byte pair tokenizer. It's by Google, which is also sort of probabilistic. The point is, if you want to break down a sentence into words and tokens in the probabilistic manner, so that basically means your outputs would also be probabilistic, right? Are you guys getting me? What I mean to say? Yeah, cool. So, the sense, what do you say in the sense probabilistic? All right. So BPE, it depends on like for example, let's say the word the, right? The word the in a BPE can actually be as like used as P and HE or even TH and E. So in that case, I'm saying probabilistic. I think Hariyan, that makes sense. All right, cool. So yeah, just going through this. So since we have quite a lot of time remaining at the end before we move on to session 3, so I'll just go through this. This was supposed to be a brownie topic, but everybody seems to grasp the topics pretty well, especially the ones who are interested. So yeah. So all right. So how many of you have heard about quantization? Can you raise up your hands? Others, Yogeshwaran went a little quiet. Sivasakti, Suryavarshini, and others. I think only Hariharan has heard about that, right? Or has anyone else has also? All right, fine, cool. Then I think no one else has heard it. So, all right, Hariharan, can you just explain what do you understand by quantization?
Sir,
Yep, please go ahead.
sir, like if they release a normal model, sir, which can be in different billion parameters, sir. Uh, and everyone doesn't have a compatible computation to run it, sir. So they will use some techniques to make the model quantized so that it will be lightweight and they can run it in their
All right,
PC or like less computation cost.
all right. So, do you know how to make that less computationally expensive? Like, what do they do
I
to
don't know
actually
the
make it?
techniques, sir. I don't know the techniques, sir.
All right. So, guys, this is going down to a little bit of maths. So, how many of you are up for a little bit of, like, let's say, okay, so how many of you are familiar with any language like C, Java, or C++? Just raise your hands. I think everybody should have done the college curriculum for everywhere. Great, great. And how many of you already know the problem that, like, about at least a little bit of a neural network, like how to train a neural network and all? How many of you know that? Okay, so I'm assuming about 7 people, right? Just keep your hands raised if you know about how to train a neural network as well as have done with C++. Just raise your hand. Keep your hands raised. Just want to have a look. All right. Fair enough. Fair enough. Cool. So I'll just share my screen and explain. Someone wrote maybe something. Okay. So somebody was. Cool. Just give me a second. Are you able to see my screen here? It's a whiteboard right now. Is it visible?
Yes, sir.
All right. Cool. So, so let's say you write a number, right? I just take in a number 1.7302000001, something like this. And I can also put in a number 1.73, right? So tell me something. If you want to write the first one in C++, how much would it take space? So like what would be the data type to require to represent this in C++?
Double, sir.
Pardon?
Double
Yes.
floating point.
Yep, you're done. Yep, it's right. Double. And for the first one?
Float, sir.
Float. Yes. And let's say we put this one. This one?
Int, sir. Or short.
Yes. So tell me something, Yogeshwaran. So what's the capacity, like what's the size of an int or a short?
Sir, something around 4 bytes, or short is among 2 bytes, sir.
Short takes in 256, right? Minus 122 plus 127. So that's 8 bits, 1 byte.
Yes, sir. Yes.
Yeah. And for int, it takes in from 30, and for the short takes in from 32,768 minus 768 to 32,767, which is 2 bytes. Int takes in 4 bytes. Float takes in how many bytes?
Sir, among 4, sir.
Float takes in 4 bytes. And double takes in?
8 bytes, sir.
Exactly. So here's the trick. So have you trained an ML model? Like any idea about how the training process for an ML model looks? Okay, I'll just bring in a photo just a second.
So something using some weights and bias.
Yes, you're on point.
Where weights will have some kind of numerical values. So when we give
Exactly.
the it will multiply with weights and we will get output as y, sir.
Yes, that's good, going good.
When we have more neurons, we will able to get some kind of likelihood, which is called as activation function, which makes everything into 0 to 1, so that we can able to get maximum likelihood, so that we can able to get y which has more likelihood, so that that will be processed as
Yep,
next one.
fair enough. Fair enough. So now let me explain you something. It's called a vanishing gradient problem. All right. So what happens is that when you try to, let's say this is the input, right? This is the hidden layer. So let's say put in a weight W1. My bad. The stroke should be a lot less. So you put in W1, right? W1 at the first layer. So W1 1. And this is going to be W1 of 2. Are you able to follow me? Hello, guys. Are you able to follow me?
Yes, sir.
Yeah. So let's put it these ways. So tell me something. So let's say in W1, W2, and W3, I have this number, right? Let's say in a scenario, I want to do W1 into W2 into W3, right? So guys, tell me something. This thing is going to require a double, right? Which is like your 8 bytes, right? Uh, Guys, I need you to be responsible a little fast because they keep your voices on, right? As much as possible. So this is 8 bytes, right? And this is 4 bytes, right? And this can be maybe, let's say if I taken an int, or let's say I taken a short. So short is gonna be 2 bytes. Okay? Alright? So tell me something. So if I do W1 into W2 into W3, right? So 8 bytes. So I have 1.7302. How many zeros? 1, 2, 3, 4, 5. 0, 0, 0, 0, 1. Right. I am doing an entire cube. Yep. Are you able to see that? Guys, I just need a quick response from you because this is going to be a little intensive for you. A little bit of approximation is needed, so we need to get this done quick. Are you able to see this?
Yes, sir.
Yeah. So tell me something. What is like what is the delta? Like what is the difference between this cube and this thing 1.73 whole cube? So if we do by the like cube root, the formula of a cube minus b cube is a minus b of a square plus ab plus b square. We have this formula, right? Or was it 3ab? No, it's ab. It's ab. We have this formula, right? If you break down a cube minus b cube,
Yes, sir.
yeah. So just changing this thing again. So let's put this thing as 0.73 since these weights are gonna be from 0 to 1, right? So we're just changing this to 0.73. अरे यार, this and this is let's put there as 0. So here the thing is, so 0.73 minus 1 0.73 cube. So that's basically equivalent to 1.7302. I can just remove this thing 0.0002 0.000001 and then whatever difference that happens, right? Something is there. So tell me something. Is this difference any significant? Like in the grand scheme of things where you have to normalize things between 0 and 1, is this difference any significant? Like with so many zeros and standing in front of 0.73? Guys,
Sir, where we can able to multiply with 10 power.
no, no. Like what I mean is take this thing, take 0.0002, like 302, and then you take 0.73. So compare these two. Are these numbers any significant? Like is 0.02 anywhere close by to 0.73 according to the scale? No, right?
No, sir.
Yep. So that's like comparing 73,000, sorry, 7 lakh 30,000 with 2, which is pretty much insignificant. So can I say that, okay, rather than storing this number in the LLM weights, I can just store this thing? I can, right? Because this thing is going to be very insignificant, right? This difference. I can just basically equate it to approximately to 0. I can just treat them as almost the same, right? Are you with me in the same page? Peeps, guys.
டேய் எல்லாம் அமைதியா இருங்கடா.
Um, all right. Anyways, so yep, this is almost 0, right? So what you can just do is you can assume that okay, you can just put in 0.73 instead of this, right? Just puts a thumb, just put react with a thumbs up if you are able to understand this. Are you able to react? You can send a reaction. Okay, fine. Sam, Hariharan, you can't understand. Okay, okay. Let me explain again. So let's say here, so in a neural network, right, you have to multiply the weights, right, with some bias. So these are neural networks. Like this is not cube, by the way. This is just a notation. I'll just make it A, B, C, right? C, B, and A, right? So now let's say I'm putting in W1 of A into W1 of B into W1 of C. Are you able to follow up from this?
Yes, sir.
Yeah. So tell me something here, since I am assuming that all of these things are like 0.732 only. So this thing 0, this will be 0, right? This will be 0. So this number minus this 0.73 whole cube, right? This number. How much will this be? I just broke it down into AQ minus BQ formula and it's around 0. These like 4 zeros, like 3 zeros and then a 2 and then so 5 zeros and then a 1, right? Yes. Yeah. So tell me something, compare these two numbers, this 0. This 3 zeros and 2 and then 0.73. This is basically 0.73, right? This is basically just the magnitude is 7300 and then the magnitude here is 2. So definitely this is insignificant, right? You can just choose to ignore it, right? When you're calculating all of this.
Yes, sir.
Yeah. So since you're calculating this thing and you can see that, okay, you can ignore and safely take this value rather than this, you can, right?
Yes, sir.
Yeah. So that means I can basically switch my double to a float, right?
Yes, sir. Yes, sir.
So that basically means for the computer, for each variable that I'm using, I am switching from 8 bytes to 4 bytes, which basically means I am like reducing everything by 50%, reducing the total model size by 50%, right?
Yes, sir.
So that's the premise of quantization. Now you can have something like integer quantization wherein you can just take in integers. So like you can just go from 8 bytes to 2 bytes directly with 75% reduction. But yeah, the model weight will suffer because you can have 0 here. And since you have zeros here, all anything multiplied by 0 will get 0, right? So the model might suffer here during the performance. But you get the point, right? You can save a lot more space here. 75%. Make sense? That is quantization. This is the part that's a science.
Sir, like ignoring a thing which is not like practically in use, then using what is ignoring the uh, double and using the float is basically reducing the number of bytes in
Exactly.
use. So
Exactly.
it is one waste.
From 8, you move down to 4, right? So that's 50%. So let's say if a
Yeah, yeah.
model that was initially, let's say 70 GB, right? You can just store it now in 30 GBs, so 35 GBs. Make sense? Similarly, there are other methods for this as well. I'm just going back to this. So pre-training methods, post-training methods. You might have seen that Meta was saying that okay, the Llama 3 first run was completed, but then we need some more training, right? That is what you call post-training here. Meta took a lot of things. They take a lot of like liberties, right? So that's one thing. A lot of companies do that. And for pre-training, it's about how you initialize the AI so that it actually gets stuff done easily. It's about initializing the weights. For example, you cannot initialize any AI with a weight of 0, right? Or 1. Because 1 multiplied with anything is just 1, or anything multiplied with 0 is just 0, right? You have to find some sort of a real number that you can adjust, keep on adjusting during the training process, right? So yeah, that's the thing. Those fall under training methods, and after the model has been trained for one run, just for more fine tuning, for just maybe reducing some flaws. Those are called post training methods. And then coming to transfer learning. So transfer learning is something that, all right. So have you ever wondered how ChatGPT can actually use to offer you fine tuning APIs that they still offer? Have you seen their offerings? It should be visible pretty much on their website. Hello. Yeah, it will be visible on their OpenAI website itself. So tell me something. The Chat GPT is like, or GPT, the models, those are so big, like around 2 TBs, 3 TBs in size, very easily. How do they ensure for so many customers that their data is like that they can have their own fine-tuned models? Like they definitely cannot buy so much storage, right? Per model, per place, per person. They definitely cannot do that. How do you think they do that? Any guess? I think I might show this tab. You might just get some hints. Focus on this part. Guys, did you are you able? All right. Sorry, Haryanan. So, like, what I mean is that OpenAI serves their fine-tuning APIs to so many people, right? So obviously their model is fine-tuned. They store the fine-tuned model, but how do they store it so that basically they can serve so many people, so many things at such less costs? Yogeshwaran, you are in the right direction. It's a step in the right direction. So, like, what do you reset? Do you reset the entire model weight, or like do you reset only a part of it? And if only a part of it, which part do you think do the reset? Uh, okay. Entrance to model. No, not really. Hariharan, any idea? All right. So there is this concept of transfer learning which is taking place. So you see, there are 5 nodes here, and these boiled into 2 nodes here, and this boils into 1 node here as the output, right? So this is the output. Keep aside everything. So this is the part that you should be concentrating on. So to save money, if you see what are which towards the output between W1 of B, W1 of C, and W1 of A, which one do you think has the most contribution? Assuming that they don't remain the same anymore. Which way do you think has the most contribution towards output? W1 of A, W1 of B, or W1 of C? No, no, Yogeshwaran, I'm not talking about the biases yet. I'm just talking about the weights here. Hidden layer, which one? W1, which one? There are 3 W1s. Be specific. W1A, W1B, or W1C? Yogeshwaran, be a little more specific. W1 ABC. Not so. Not really. Alright. So if you, yep, W1C. The correct answer is W1C. Rangesh. Alright, Rangesh is a new name. That's nice. Nice to see you interact. So yep. So W1C it is. So if you see, like, just keep these, like, just keep a differentiation, and like if you see that this is 0.73, if it changes to 0.72, right? Either way, if it changes to 0.72 and this changes to 0.74, the output won't matter much. But if this changes from 0.73 to 0. Let's say 74, then the output would change by a huge margin. Like compared to the others, it would change significantly. And if you also see this layer, this last hidden layer actually has a lot less elements. Are you able to see? So it's 5, here 3, here's 2, right? Guys, even a yes or no would be here. Yeah, cool. So what you can technically do is you can just swap these things. Like you can just freeze these weights, all of these cumbersome weights, and you can just let the user train on this layer maybe just to alter these weights, right? I mean the other internal deep layers, think of like deep depth of 20, 30, 40 layers. In that case, it won't make sense, right, to go near the entrance or be in the middle, right? I think somebody can maybe speak up. Kind of.
Sir,
Yeah, are you able to understand, Hariharan?
sir, like you are saying, we should just concentrate on layers which are very
Exactly.
contributing to output, and we should freeze the other hidden layers. Sir. So
Exactly.
because there are so many hidden layers,
Exactly. That's what I'm saying.
sir, and I also have a doubt, sir.
Um, yeah,
Uh,
yeah,
Sir,
Hariharan.
like last week, I learned about that. I just saw an article about low rank adaptation. Sir.
We'll come to that later. So low rank adaptation, quantized low rank adaptation, those are different. We'll come to that because quantization itself is something that we took a lot of time to go through, right?
No, sir. I just saw what is it in that also there is we should freeze the LoRa layer and then we should train so that it will be quantized.
That is when you have a low rank adaptable model, and then if you want to fine tune that,
Fine,
that's
sir.
a different thing.
Fine, sir.
We'll come to that later, or like we would definitely be up for discussion for that. No worries. Yeah, somebody else is also speaking, I guess. All right, fine. So this is what you do. This is actually an example of transfer learning. You just swap these matrices by training on their data and keep all of these freeze. So what OpenAI does is it just keeps this thing freezed, like it just keeps this thing, it just stores this thing for the user, this one matrix. All of the rest of the GPT model is fixed. That basically helps them store data while also serve you at very, like, serve users at very low cost, albeit a bit higher than the standard API. Make sense? Cool. Kind of feel that okay, I'm teaching only a, like I'm helping out only a handful of guys here, but fair enough. All right then. So yep, I think most of that we'll be sort of we are done with like session 2. If you guys have any queries, the floor is open. Just go and ask with your questions. Oh,
Sir,
yeah, please go ahead.
sir, no, sir. I have a doubt about the long chain, sir.
About the
Long chain, long chain.
long chain or lang chain?
Lang chain, lang chain.
Yeah, but
Sir, no, sir. I was like implementing a small chatbot on that, like using DeepSeek model. Uh, sir, can you hear me, sir?
yep, sure. You can just shoot a
Ah,
DM. Won't be an issue. As well as like we'll be discussing coming to lang chain and everything on session 3.
okay, sir.
Yep. So like all of these things will be done. Like today is only for the foundation so that you can get an understanding, okay, what is the intuitive model of an LLM, how LLMs can be useful, what to do, and slowly we'll transition to RAG, then agents and whatsoever. Don't worry, I've got it planned.
Fine, sir.
Yep. I mean, you have done it, but most likely the others haven't done it yet. Or like you can just send a DM to me. I can just answer in the break time. So guys, the floor is open. Anybody else with any other question? Okay. I think we are then sort of done. Sampath sir, are you there? Hello. Um, is it possible to convert image to text model in text to image? Um, Using the fine tuning capabilities, you mean Yogeshwaran, like the transfer learning?
Okay, sir.
Yeah, do you mean like in transfer learning to you want to convert? Do you mean in that in your question?
வழியா convert பண்ண முடியுமா?
No, sir. I'm asking about open-ended, sir.
Open
Sir, in any way we can able to convert, sir.
image to text model to image. Okay, so like OpenAI ChatGPT isn't just one model, by the way, if you don't already know. So it has multiple models working together and it has an agent, which is why I told you to go to Claude, right, to test out those prompts so that the liveness you can understand. But OpenAI, what it will do is it will automatically search the web. That's not the model. That's a system attached to the model that searches the web if it finds the intent to search current data or some person name. Yes, so Sampath sir, I think we are wrapped up with the session 2. The everybody is asking us some questions. You can just you can just maybe close the recording for session 2, and we can just resume from session 3. Yeah, yeah, sure. Sure, sure. Yeah, guys, if you have any question, feel free to ask here, or if you don't, you can just go drop off to lunch. I'll drop off in a minute or two as well. If you want to ask something, now is the time. So yeah, Yogeshwar, it was like about the OpenAI models, right? So OpenAI models, number one, are multimodal in a way that is they can understand text, they can understand images, but they cannot generate images from a text model. That requires a different support system tool itself. They use that to identify the intent of the person if they want to generate a like image or not, and from that they parse the argument, the query of the user, and send it to the image model, which gives you the output. Because it is done in one system, it gives you the illusion of one model itself, but it is not one model. It's multiple models working together. Does that make sense?
Yes, sir.
OCR model, not really. So OCR models are just visual recognizers. These are something called VLMs, visual language models, like vision language models. My bad. So those are different. So like yeah, like VLMs have a larger use case. Like they are like a very big subset, like superset basically. And OCR can be one part of it. For example, Mistral recently released one Mistral OCR, which was a offering and a scenario covered by their VLM, but it's not the only thing. An OCR model cannot do all the tasks that a visual language model can do, but a visual language model is theoretically able to do all the tasks that an OCR model can do. Make sense? Cool. All right. Does anyone have any other question, or I think we can just like pause and go and have a lunch. All right. I guess then we should go and have some lunch. Yep, guys, go and have some lunch. Like I know you're all hungry and everything. Even I am. See ya. Back in an hour. Then.